Hi friends and my dear students. Now, today in 12th Physics, Unit 8, Atomic and Nuclear Physics. The very important and very easy chapter. I hope you understand clearly, then you get more marks in your examination without any memorizing. You once listen my classes, then you automatically can gain the knowledge. Now, what is meant by atom and what is meant by nucleus or nuclear? Atomic physics or nuclear physics? Is there any difference between? Yes, sir. When we totally study about atom, that is called atomic physics. When you are studying inside the nucleus itself, then it is called nuclear physics. Now, before that, we have to see some introduction. What is meant by matter? What is meant by matter? Matter is nothing but those occupies the space is called matter. That's all. Matter, it is nothing but those occupies the space is called matter. That's all. The matter can be classified into three main groups such as gas or liquid or solid. As per our convenience, we are utilizing these three state of materials according to our convenience. We can use the gases, we can use the liquid, we can thus use the solid in different way in day-to-day our life. That's a very important concept. Now, is there any fundamental property or differed from gas, liquid or solid? Now the matter may be act as in two different ways. One is it may differ according to the physical phenomena and the chemical phenomena. That is, when you consider gas, the physical property of the gas may be differed from the chemical property. In same manner, liquid may be differentiated with the physical property as well as chemical property. In the same way, solid also. So we cannot fix all the three are same in physical as well as chemical property. That's why we must learn what is the entity of matter. What is the entity of the matter? That's the thing. The scientists are focused to invent the entity of the matter. Entity of the matter, let us assume this material of big size. If you consider half, then it may be a smallest. If you consider 1 second half, then it may be smallest. If you consider 1 second small, likewise you have to minimize like then at a one certain stage you cannot indivisible this particle in the ordinary method. Such a smallest particle is considered to be an atom. Such a smallest particle is considered to be an atom. Atom cannot be divisible furthermore in normal methodology. That's called atom. Okay. If the atom cannot be divisible, then how can we understand the entity of the atoms? Let you imagine an atom. This is called an atom. This is called a nucleus. When you consider the radius of the atom, 10 power minus 7. This is called 10 power minus 7 meter. When the radius of the atom is called 10 power minus 10 meter. Within this smallest particle, proton and neutron are accumulated in the same nucleus, whereas electrons are revolving the nucleus around the orbital. This is negatively charged and this one is positively charged. This is zero charge. There is no charge for neutron. So that we conclude this among these particles are the fundamental particles of the atom. So is this entity of this fundamental particle? No, some other particle may be called as entity. Entity means அடிப்படையான ஒரு இப்போ if you want to study about the universe, the sun, then among this there will be 9 planets, or except sun there will be 8 planets are revolving the sun. So when you think about to identify the which is the causes of this universe, how can the universe which will be created become a tiny particle. Explosion of this tiny particle is called universe. In such a manner, scientists want to identify the entity of this proton, neutron, and electron. That's why they are concentrated about furthermore to study about the invention of the fundamental particles or entity of this particle. That's the goal of our to study about the atomic and nuclear physics. Now, this is the introduction of this chapter. Okay, are you clear? Yes, very interesting. But you can observe it is tremendous physics. Not physics, a tremendous and very tasty physics. Very good. If you are thinking about and any gas, these are all called gas. Generally, gas are considered to be poor conductor of electricity. Electricity, normal pressure under the 76 centimeter mercury pressure, the gas is considered to be a normal. It is a non-conducting substances. There is no charge. It is a neutral particle. Gas are consist of neutral particle. There is no any charged particle. That's why we are alive. So under the normal atmospheric pressure called 76 centimeter mercury pressure, there is the gas are considered to be a poor conductor of electricity. Now, is there any device to convert the gas to become as a conductor? Is it possible, sir? Why not? Possible. That's why we are making some arrangements under such a tremendous situation we are creating. That's by means of an apparatus is called discharge through gases. Discharge tube through the gases. That's we are going to see now. Discharge tube through the gases. Now let us imagine you have to consider like this. The tube, diameter of this one is called 4 centimeter. The diameter which is called 4 centimeter and the length is 50 centimeter. Diameter is called 4 centimeter. Inside that pure air at 76 centimeter mercury pressure. Okay. Now, in one side we are adding side wall and we are adding diffusion pump. What is the use of diffusion pump? We can evacuate this gas to outer side by putting on the diffusion pump. That's the uses of diffusion pump. So that now you have to open this one, not closed. You have to open the diffusion pump are open so that air inside are called 76 mercury pressure. And here let us imagine an induction coil. This is called primary, and induction coil, that is called secondary. When you are giving high voltage to the primary, it causes to the induction voltage in the secondary. And such a cases, we are applying, this one is negative or this one is suppose positive. For example, 50 kilovolt, when you make this primary induction, you have to increase primary induction voltage up to that we are getting 50 kilovolt in the secondary. Up to that we are increasing the value of higher voltage to the primary, so that we are able to get 50 kilowatt in secondary. Such as negative voltage are connected with the cathode. This is called cathode negative voltage. And positive, which is called nothing but anode terminals. This is called anode and positive. At the mercury pressure of air, what is the pressure inside the air? 76 centimeter, or you may write 760 millimeter, right? Okay. Now, is there any happen between anode and cathode? Nothing. You can't see any changes in the inside the tube or between the terminals of anode and cathode. This is the first stage, 760 mm, there is no change. Then if you are reducing 110 mm mercury pressure inside the tube, by utilizing diffusion pump, you are evacuated the air or pressure inside the tube are reduced with the help of the diffusion pump. Then the pressure inside the air is called 110 mercury pressure. Is there anything happened? Nothing, sir. So these two is not happened any changes in the inside the tube. Then again we are reducing 100 mercury pressure. 100 mercury pressure. Then we are having crackling sound and irregular beam which are emitted by anode to the cathode with the sound of crackling sound. That's the important concept. So the scientists have suggested that why anode are emitted towards the cathode with a crackling sound. There is not in proper way, but a sound may be chada 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 like that, crackling sound like that. So again they reduce 10 mm mercury pressure inside the tube. Then there is a uniform positive ray which are entered to the anode to the positive. This is called positive rays which are emitted by the anode at 10 mm mercury pressure. At 10 mm mercury pressure inside the tube, then there may be a ray which are emitted by the anode to the terminals of cathode. That is, these are all positive rays. Again, they reduced the pressure inside the tube 0.1 mm mercury pressure. 0.01 m mercury pressure. Then the positive column, the positive rays and positive column which will disappear at the mercury pressure, that is called completely dark space. This was invented by the Crookes. That's why this is called Crookes dark space. Crookes dark space. Crookes dark space. This is a very important concept. You have to understand clearly. Crookes dark space or happen at the mercury pressure of 0.01 mm mercury. But apart from this, there may be a fluorescence which are happened in the terminals of anode as well as a green colored fluorescence which are happened throughout the tube, throughout the discharge tube or available, or you can be able to visualize the color but you cannot be able to visualize the particle which are moved from where it was, where it comes. That's why the scientists are confused how it was happened, why it was greenish glow that are possible at the terminals of anode itself. At last, they conclude that this was emitted by the cathode because there is no glow in the cathode, negative terminals. So, the negative terminals which will emit some ray, and that's why the glow was happened. The glow was happened, and that glow is called cathode ray. This is called cathode ray. Cathode ray which are formed and move towards the anode. That's why whenever it moves towards the positive plate, then it will possess the negative charges, and this must be an electron, no other way, because negatively charged particle only are attracted by the positive terminals of anode, so that cathode ray consists of negative particles and nothing but an electron. Nothing but an electron. This is a very fantastic phenomena. They invented the cathode ray and positive ray. Positive ray at the 10 mm mercury pressure, it traveled from anode to the cathode. When the mercury pressure inside the tube are reduced 0.01 mm mercury pressure, then the cathode ray which are formed and travel from cathode terminals to the anode. This is a very fantastic result. He concluded and invented the cathode rays and positive rays. Then, this is the experimental introduction. Now, if there may be able to get cathode ray, and what are the characteristics of the cathode rays? That's a very, very important 5-mark question. 5-mark question. Very important 5-mark question that we are going to see now. Are you clear? Yes, I hope you may understand.
Video will be stopped. Video will be stopped.
Okay. Yes, characteristics of cathode rays I have to put in second another video because some problems that was handled happened in the video. That's why I have to start the cathode ray principles in the next classes. No problem? Okay, let us start. What is the uses of cathode ray? What is the characteristics of cathode ray? Cathode ray. What is the uses of cathode ray? Cathode ray uses are classified into 7, as far as I concerned, 9 important characteristics. But as far in our textbook, there may be only 5 characteristics, they are combined together and they give all important points, or 9 points are given in our textbook, but they are clubbed into one by one. That's why it is very difficult to memorize it. So by simplification, I am giving one by one. The first point, the cathode ray is nothing but cathode ray possesses energy as well as momentum. Cathode ray consists of energy as well as momentum and travel with velocity equivalent to 10 power 7 meter per second in straight line manner. Cathode rays are travel in straight line manner with velocity of 10 power 7 meter per second. Third one, when deflected, when you are applying this cathode ray through the electric field, positive and negative, these are all electric field E, and the charge of the cathode ray is called E, therefore E into E is electric field. And because of this electric field, the path of the cathode ray may deflect towards the positive plate. That's why the path may be deviated by means of electric field and it moves towards the positive terminals. That's why it must possess negative charged particles. That's why the electron possesses negative charged particle, so that cathode ray it is nothing but electron ray. That's one important part, electric field. Suppose if you are applying the same cathode ray in an magnetic field, what will be the causes? This is called magnetic field. Magnetic field B, again the path may be deviated in opposite direction to the electric field. So that we conclude that the cathode ray charged particles are negatively charged particles which are affected by either electric field or by magnetic field. This is a major property or characteristics of the cathode ray. Then fourth one, when the cathode rays are allowed to fall matter, when we allow this cathode ray to fall on any matter, then the heat energy are evacuated. Heat or energy are evacuated by means of this cathode ray. The fifth one, if it can be deflected by application of electric and magnetic field, the direction is a fifth point. They affect the photographic plates. Suppose if you are sending the cathode ray and through any object, if you are putting photographic plate here, then this photographic plate was affected by means of this object on the photographic plates. This shows that this cathode ray which affect the photographic plate. Sixth point, very important point. Whenever it hit the surface of some certain crystals and crystals as well as minerals. This is called minerals. This is called crystals. Whenever you are allow the cathode ray hit the surface of crystal, the fluorescence may take place. The same manner, when you are applying the cathode ray on minerals, then the fluorescence may take place. That's a very important point of seventh important point. When the cathode ray hit the high atomic mass material. High atomic mass, high mass, high atomic mass, high atomic mass. That means A is high. A is high. Then X-rays are produced. X-rays are produced. We already studied in the previous chapter. When the cathode ray, whenever hits the high atomic mass materials, then X-rays are produced. X-rays are produced. And the eighth point, eighth character, when it travel through the gas or neutral particle, when the cathode ray hit any particular neutral particle, then it will become ionized. So it has a tendency to become ionized the gases. That's the important point. When cathode ray passes through the gases, the molecule constituted by the gas become ionized. So this is a very important eighth point. And the last point, it travels with velocity of 1/10th of the velocity of the light rays. These are all 9 important characteristics of cathode ray. It's a very important. I think if you are able to take this kind of simplification hints, then you should not memorize the concept as per in your textbook. You can straight away go and write the 5-mark question. You will get sure without any, they are putting tick mark and get 5 mark itself. That's all. This is a very important question for 5 marks. Thank you, my friends. I hope you understand this concept and enjoying atomic physics and nuclear physics. Now, one by one, we are clearly explained throughout the chapter. In separately, I have to solve all 7th chapter sum in the evening itself. One per day 3 sums, then you will get answer for all sums for exercise sums. If those who are not subscribed my channel, please subscribe. And if you need continuously watch my channel, you put click bell for all button. Thank you, my friends. Thank you.